All right, so example 3 says find the gradient function of y is equal to sine x plus 2 cos x. So of y is equal to e to the sine x plus 2 cos x. Not easy, not hard. So if I want to write it, this will actually take up much space. This is e to the sine x plus 2 cos x. If I differentiate e to the x, I'm going to get back e to the x. You should see that this is a composite function and that the inside function is sine x plus 2 cos x. So dy by dx would be equal to e to the sine x plus 2 cos x, which is the differential of the outside function, multiplied by the differential of the inside, which is if I differentiate sine x, I'm going to get cos x. And if I differentiate cos x, I'm going to get minus sine x. So this is minus 2 sine x. So if I want to write it pretty, I could probably put this as cos x minus 2 sine x multiplied by e to the sine x plus 2 cos x. All right. Did you get it? Say yes.
Yes, sir.
All right, the next. This says find the gradient of the curve. Well, everybody should know that dy by dx is the gradient function. All right, is the function that is used to calculate the gradient of the curve. So if I say find the gradient of the curve at a point, I need to first find dy by dx. So y is equal to 5e to the 3x cubed plus 2x. Dy by dx would be 5e to the 3x cubed plus 2x. Then I have to multiply by the differential of the inside function, which is here. 3 is 9, so this is 9. Decrease the power by 1, so it's 9x squared. If I differentiate 2x, I'm going to get 2. So my final answer is 9x squared plus 2. I'll probably put the 5 at the front, 5, and then e to the 3x cubed plus 2x. All right, now when x is 0, because we need to find the gradient when x is 0, when x is equal to 0, dy by dx, which is the gradient of the curve, the instantaneous gradient of the curve, would be equal to 5, 9 times 0 squared plus 2 e to the 3 times 0 cube plus 2 times 0. So of course, the power is going to work out to be 0. And inside the bracket is going to work out to be 2. So my final answer is going to be 2 times 5, which is 10 e to the 0. Anything raised to the 0 power is 1. So this is 10 times 1. The answer is 10. Did you get that?
Yes, sir.
All right. If you differentiate ln x, you get 1 over x. If you differentiate ln ax plus b, you're going to get 1 over ax plus b, and you have to multiply by the differential of the inside function, which is a. So the answer is a over a plus b. So example 5, dy by dx in one go would be equal to 6 over 6x plus 3. If I wanted to, I could simplify that. This is 6 over 3 into 2x plus 1. If I want to, I didn't have to. This is 2. And so the final answer would be 2 over 2x plus 1. If you didn't do that, I guess it doesn't matter so much. You could have just left your answer here. All right, turning the page. This says, 6 says, find the derivative of y equals that. So y is equal to ln cos x minus sine x. So this is a composite function, and the inside function is cos x minus sine x. dy by dx, when you differentiate ln, you get 1. ln x, you get 1 over x. So this is 1 over cos x minus sine x. Then we have to multiply by the differential of the inside function. We differentiate cos, you get minus sine. So this is minus sine x. If we differentiate sine, you get cos. So this is minus cos x. If I want, I could just filter out that negative and say the answer is minus sine x plus cos x over cos x minus sine x. Any trouble? Any issues? No problem?
No, sir.
7. Let's differentiate. So y is equal to ln e to the x plus 6. Composite function again. dy by dx. This is equal to e to the x plus 6 at the bottom, 1 at the top, multiplied by the differential of the inside function. If I differentiate e to the x plus 6, I'm just going to simply get back e to the x. So my final answer here is e to the x at the top, at the bottom, e to the x plus 6.
Sir, I have a question.
Go ahead.
Well, a query. Sir, for example 6, where you say you filter out the
Minus 1.
sign. Yes.
Yes.
Would you just leave it right there like that?
You could. You could have just left it as this. Minus sine x minus cos x, and this is all over cos x minus sine x. It's the same thing. But what I did is simply factor out the negative 1 at the top. That's all I did. But these two answers are the same. Any other question?
Yes, sir.
We're good? All right, 8. All right, so this now, we could either make it complicated or easy. Y is equal to ln x plus 1, x plus 1 over x plus 2. I'm going to use this law of logarithm, that the log of a minus the log of b, I can make this into one log by dividing. So this is the log of a divided by b. So the reverse is also true. If I have one log, I can make it into 2 log. If I have 1 log and I'm dividing, I can make it into 2 logs by subtracting the logs. So I could say that y is equal to ln x plus 1 minus ln x plus 2. Any problems with what I just did?
No, sir.
Good. So now let's differentiate. We know how to differentiate ln. So dy by dx would be equal to 1 over x plus 1 minus 1 over x plus 2. Very easy. Once we did that, if we didn't, it would make the entire thing complicated. Doable, but complicated. All right, doing it like this by splitting up the log makes it a lot easier. All right, so let me stop the video here, and then we'll look at a few more questions.